Hello everyone, myself Dinesh Kumar, and in today's lecture we'll be discussing about hashing techniques, right? So this is agenda for the today's class. We'll be discussing about hashing, need of hashing, various hash function and their examples and applications of hashing, right? So first thing is, why do we need hashing? See, we have studied various data structure like arrays, linked lists, trees, graph. See, if we want to perform any, we want to store large amount of data using one of these data structures, and we perform some search operation, then the best performance we can have is of order of log n. See, if in case of binary search, the search time required is order of log n, right? And in case of linear search, it is order of n, right? So but we want something better, right? So to perform a search on this, see, we have various applications where large amount of data is stored. So where in that case, when a search operation is performed, then we want it to be order of 1 or near constant time, right? So solution to this problem is hashing. See, one thing is that we have a something like this, that we have a set of key values which we want to store in, for example, this 1, this 2, this 3, we have 4, we have like 5, 6. These are nothing but these are the key values, right? These key values which we want to store in a table, right, in an array. So what we do is, like, for example, we have this array, and this array has various location. It's a linear kind of data structure, right? This table we call hash table, right? So it is starting from 0, then we have 1, we have 2, 3, 4, 5 and 6, like this. So in direct addressing, what we do is, see, if we have a key 1, then we will store this key into this index 1. If we have it 5, then we store this into index 5. So this is direct addressing, right? But this method is not efficient. Why it is not efficient is, let's suppose we have very few number of keys, right? Let's suppose if there is a one more key is there with this value 200, right? So in that particular case, then the size of this array must be equal to 200, right? Only then this 200 can be stored at that particular location, right? So but how many keys we are actually storing? We have 1, 2, 3, 4, 5, 6 and 7. To store these 7 keys, we need arrays of size, how much? Of size 200, right? So this is the disadvantage of using this direct addressing, right? So we must use some other method to map the key values from a set of these keys to the data structure, right? So this data structure, this array, we call it a hash table. We need some function to map these key values to one of the addresses, right? So let's come to hashing. Hashing is, first thing is the hash table which we have used. Hash table is what? Hash table is a data structure in which which keys are the data which we want to store in the data structure, right? In which the keys are mapped to the array position. Array position means actual address in the array, right, by a hash function. So a hash table is an element with a key k, and an element with a key k is stored at some index of the array, and that index is given by h of k. We will calculate this, where h is a function. We call it a hash function, not k. Like in previous case, if we are having a value, let's suppose key is having value 1, then we are storing it at index 1. But here we are not doing this. We are given a value key which we want to store. We are performing some function h of k. H is a function. We call it a hash function on it, and then the address is generated, index is generated where that key value is going to be stored. Okay, so it means what hash function is, hash function h is used to calculate the index. Hash function is used to calculate the index at which the element with key k will be stored, right? So h is nothing but it is a function, some mathematical formula or mathematical function which we need to perform on the given key, right? So that we can calculate the actual address of the array where we can store that particular element, right, that particular key. So the process of mapping, this process of mapping the key values to the appropriate location in the hash table, this complete process is called hashing, right? So this is hashing. Hashing is what? Hashing is the process of mapping the keys from a set to the appropriate location in a hash table, right, with the help of hash function. This is called hashing. So hash table is what? Hash table is the table in which each key from the given set of keys are there which we want to store, and then each key is mapped to the locations generated by the hash function. And one more thing, that if given a key k1 and we apply some hash function h on it, and it will generate a address, let's suppose z, right. Another key 2, you apply the same hash function and it will again generate the same address, let's say z1 again. So in this case, when more than one key is mapped to the same location in the array hash table, then we say that collision has occurred, right. So there are ways to minimize collisions, right. When we select hash function, then we consider these things, right. So first is a hash function is simply a mathematical formula. What is hash function? It is simply a mathematical formula which, when applied to the key, produces a integer. Integer is nothing but it is the index into your hash table, right, which can be used as an index for the key in the hash table, right. So hash function are used to reduce the number of collisions. So this is important. Hash function is used to reduce the number of collisions. So in practical, there is actually no hash function which can totally altogether eliminate the collision completely, right. But we can choose hash function in such a way that the number of collisions can be minimized, right. There are ways to select hash functions such that the number of collision will be minimized, right. So now if you use hash function to map a key value to a actual address, then we have two things. One is the number of collision can be minimized. Second thing is that your memory requirement, like in the direct addressing hash table, more memory is required to store less number of key. That problem is also avoided, right. So there are various hash functions. There are various variations on these hash functions. So some of the commonly used hash functions are these, right. So these hash functions are these. One is called the division method, or sometimes also called division modulo method, right. Another one is multiplication method, mid-square method, and this is folding method. Sometimes folding on the boundary, and the this folding method also, right. So we'll see them one by one and discuss their example, right. So first one is this division modulo method. See what in this division modulo method is, what we do is that it is the simplest method of hashing, right. Hashing an integer k is the value, key value which we want to store in our using hashing, right. And hash function in case of division modulo method is what this hash function in our division modulo method is this: h of k is equal to k mod m, right. M is what? M is the size of the hash table. M is what? M is size of the hash table. And key is what? Key is the data which we want to store in the hash table. So using this hash function h of k, which is k mod m, we actually calculate the actual address in the hash table where we can store this value k, okay. So the method it is very simple. It simply divides k by m and then uses the remainder, okay. Now see one example. So in this case, see this, we are given the key value is this 1 2 3 4, right. Given this key value 1 2 3 4 and given a hash table of size 10. Hash table of size 10 means we have a table like this, hash table which we are calling. We have a table like this, and this table has how many locations? This table has 10 locations like this. This table has total of 10 locations. So it is starting from 1 2 3 4 5 6 1 2 4 5 6, then we have 7 8 9, okay. So this is your this is 7 8 and 9, okay, 0 to 9. So size of the hash table is our 10. So we want to store this value 1 2 3 4 using the division modulo method in the so how do we calculate the index where this key 1 2 3 4 can be stored? So what we do is, see, our hash function is key mod Hash function is key mode m. Key mode m. Key value of key in this case is 1 2 3 4. Mode operation, and then size of the table is 10. So this will give 4. So 4 is the index at which this key 1 2 3 4 can be stored. So 4 is here, so we can store 1 2 3 and 4. Okay, so this way, if another value we want to store, like let's suppose my next key value is 456. So how do we store this key 456 into the this? So again I will calculate using the size of the table is 10. So now my address will be, this will be 6. Okay, so I will store 456 on location 6. So it is 456. This will be stored at location 6, index 6, right? So this way, using the division modulo method, we will calculate the index in the hash table where a given key value can be stored, right? So then we have next method we have is a multiplication method. Multiplication method, see, this is the simple procedure. First we choose some constant a, and this constant a will be chosen between 0 and 1. Okay, 0 and 1, and we'll multiply the key by a. Okay, we'll calculate k into a. A is some value between, which is between 0 and 1, right? And then we'll multiply the key value with a, and then we extract the fractional part of this multiplication, k and a, where a is a some value between 0 and 1. K is the key which we want to store, and we'll multiply these two and extract the fractional part, right? And then this fractional part will be multiplied by m. M is what? M is the size of the table, and then whatever you get, you take the floor value of that. Okay, whatever you get, you will take the floor value of that. That will be the actual index in the hash table where you are going to store that k. So hash function in our case is, see, this k into a. Hash function in this case is k into a. K is what? K is the key which you want to store. A is some value between 0 and 1, and this mode operation is to extract the fractional part only, right? And then you will multiply it by m, and this m is what? M is nothing but it is the size of the table. So whatever value you get after this calculation, you will take its floor value. You will take its floor value. So that will be the actual address of the hash table where you are going to store this particular key k. Okay, let's see by an example. See, in this case, our table size given is 1000, right? And we want to store this key 1 2 3 4, right? So in this case, what we have is, we have a table like this. We have a table which I'm talking about our hash table. So our hash table is starting with some value 0, right? Similarly for value 1. So like this, we have somewhere here we have value 500, right? So somewhere similarly, say, let's suppose here we have value 617, and this, and then up to some last value will be 999. Okay, this is your hash table. So this is the first location of the hash table, starting from 0 up to 999, right? So you want to map a given key into this hash table, so using the multiplication method. So what multiplication method does is, see, we have chosen some a is some value between your 0 and 1. So we have chosen 0.618030. It may be given in the question, or you can choose some value based on what hash function you are using, right? And a is some value between your 0 and 1. Then m is the size of the table which is given at 1000, and key which you want to store is 1 2 3 4 5. So this key 1 2 3 4 5 you want to map into this hash table, right? So how do you do that? See, remember our hash function. Hash function says that first calculate k into a. First, see, this is, in this particular case, this is what? This is our key. You multiply this with the a. You multiply this with the a. After this multiplication, you will get this part, 7629.610. And when you take a mod with 1, then it means you are extracting this part only, right? You are extracting this part. See this, 0.617385 5. You have extracted the fractional part from this multiplication, right? After this, what you are doing is you are multiplying this with the m is what? M is the size of the table. Okay, m is the size of the table. Then whatever value you get, out of that value you take the integer part only. That integer part is the actual index in the hash table, where this given key value k, which in our case is 1 2 3 4, which in our case is 1, which in our case is 1, which in our case is 1 2 3 4 5, right? So this key value will be stored at this address, right? This will be stored at this. So again, what we have done is we have chosen a value between 0 and 1. We call it a. We want to map a given value k to the hash table using multiplication method. So we'll multiply a with k, right? And then we'll take the fractional part out, and that fractional part will be multiplied with the m. M is nothing but the size of the table. And then whatever value you get, take the integer part only. That integer part will give you the index of the hash table, where the given key value will be stored. Like in our case, it is 617, right? So there can be any number of keys. At maximum, you can store 1000 different keys into this table, right? If no collision occurs, right? So collision can always occur, right? Depending on the number of collision can be reduced, but yeah, you cannot avoid collisions totally. We'll discuss the collision and collision resolution technique in some other lecture, right? So another method of hashing function is mid-square method. Mid-square method is, see what it says, two steps. First is that square the value of the key. K is the key, and you take the square of key value, right? And then extract the middle r bits. Then extract the middle r bits. Then extract the middle r bits. Middle, see, how do we find r? R is the maximum digits in your table, hash table, right? Let's see this. So h of k means hash function in this particular case is nothing but it is first you calculate the square of the key value and then take out the middle r bits, okay, and that r bits gives you the actual address of the actual index of the key of the hash table, where you can store the key, given key, right? Let's understand this by an example. So see, our given question in this particular case is that we can calculate the hash value for the this key. So this is 5642 is the value which we want to store in our hash table, right? And method which we have to use is mid-square method, right? And size of the table in this particular case is size of the table is 100, right? So value of m in this particular case is 100, right? So it means we must be having a table like this. We must be having a table like this, right? So first address will be 0 and last address will be 99. Now see how many digits are required for the storing these indexes. So in this case maximum size is 99, right? So in this case maximum size is 99. So 99 is 2 digits. So value of r in this particular case is 2. So value of r in this particular case is 2. See, we have written this also. We have a key which we want to store is 5642, and the hash table has a 100 memory location. So this is 0, then 1, 2, 3, 4 up to some 100 memory location, and we need to map. See, what we need to do is in mid-square method, first we calculate the square of the key value. So key in our case is 5642. We multiply it by itself. We calculate the square of it. Okay, we calculate the square of it, and then we extract the middle 2 bits. Why 2? Because total locations are 0 to 99. Only 2 digits are needed, right? So these 3 are left. These 3. So middle 2 values, and that will be 32. So it simply means is that somewhere on this table at index 32 we will be going to store this value 5, 6, 4 and 2 like this. Okay, so this 32 is nothing but this is the address or index in the hash table where we will store this key value 5642. Now see, it might be possible that given a key value and its scare is something like this. Let's suppose 1 2 3 4 5. Okay, let's suppose h of k means scare, after scaring a key value you will get something like this, and r value of r is equal to 2. Then it is up to you that either you take 23 or you take 34. Okay, see, because there is no way that either you need to choose 2 bits, right? So you can take either 23 or you can take 34 also, so anyone will be correct, right? So as per the mid scare method, right? So then we have folding, hashing by folding. See, in this method what we do is we divide the key. Key is the key which we want to store into the, which we want to map into the hash table, right, into a number of parts, right? And that divide the key into number of parts like k1 k2 up to some kn, and each part of the key will be of equal length, right? Each part of the key like k1 k2, if k1 is of 3 digit long, then k2 must be of 3 digit, k3 only the last one kn can be can have less number of digits, right? So, and after that, first part is divide the key into various parts of equal length except the last part, and then add the individual bits like k1 k plus 2, add all these together, right? And finally we the hash value is produced by ignoring the last carry if any. Now we'll understand this by an example. See, given a hash table of this 100 location, so again in this particular case that we have, what we have is we have a table like this where we have total locations are 100. This is location 0, location 1 and up to this is location 99. So this is your hash table, right? This is your hash table, right? So this hash table, so in our case m is equal to 100. M is the size of the hash table, right? Calculate the hash value using the method folding method, and this is the your key 3 which you want to map into this particular hash table. See, so in this particular case key parts are key, why 2? Because 0 to 99, again because we have these two digits, so we'll be using these 2. So first we divide 3 4, then 5 6, k1 is 3 4, k this is 5 6, and because the last one can have the less number of digits, we have 7. So these are the this is your k1, right? This is k1, this 56 is k2, and this is your k3. We have divided this given key into 3 parts, k1 k2 and k3, and then we add them together. 34 plus 56 plus 7, the total final value will be 97. So it simply means that this particular, see, this will be 98 and this location will be 97. So it simply means that this key, which is 3 4 5 6 7, this key will be stored at location at index 97 in this particular hash table, right? Is it clear? Okay. So then we have already said this, that there are various applications of hashing. In fact, hashing is used in web searches, spell checkers, databases, compilers, password, and many others. So in case of compilers also, like whenever compiling a program, all the variables and identifiers declares in your program are stored into the symbol tables, like, and there is, you need to look up for this. Similarly for the spell checkers, database, where web searches where large amount of data is stored. So hashing is hashing will improve the performance of searching, right? So, and there are other factors like how do you choose a good hash function which will minimize the number of collisions, right? So one thing is that never choose a table size which is in power of 2. Okay, so table size should be a prime number, but it should not be closer to the power of 2 raised to power. It cannot be. It should not be closer to the power 2 raised to power k. Right. So if it is, then the performance will be reduced. Performance will be reduced means then more number of collisions will occur. Collision means more than one key will be mapped to the same location. So if more number of collisions are have occurred, then you need to do something to handle those collisions, and this will degrade the advantage which hashing will give you by improving the efficiency of search operations, right? So thank you.